هما Soviet Russia ve devi kabi ki Çin'e gelip de Kazakistan
normal visual. Tamam.
Yeah, Dr. Risa, I think so it's time now. We will just maybe take a few seconds and then we can just start. Maybe just another 30 seconds. We see some people joining in. I think so we will start now. Is that okay? Dr. Risa?
Excellent.
Okay.
Yes.
So, hello everyone. Good morning and good evening wherever you are on this planet now. And say, Angnang Hasyo, Swadika, Salamat Pagi, Namaste, Ni Hao, and thank you all for attending today's workshop. Please note that this workshop will be recorded, and if you don't wish to be recorded, please turn off your camera. And I would like to introduce now our team. We have Sebyul, who's just sitting beside me here in Bangkok Asia office. Here, the IUCN Asia Regional Office in Bangkok. And Sebyul is on the secondment from Korea National Parks, and she has been leading the protected area work here in Asia and helping as a program officer for the protected areas. We are also joined from the other side of the planet is Madeline. Madeline is the technical and administrative assistant for Best Practices Guidelines for the Climate Change Mitigation in protected areas. And finally, I would like to welcome the main person who's leading this effort is Dr. Risa Smith. She's an ecologist and the chair of IUCN World Commission on Protected Areas Climate Change Specialist Group. She has written many position papers for IUCN, reports and peer-reviewed papers, organized workshops, and given many talks on the role of the protected areas in climate change mitigation and adaptation. Today, she will introduce you to the project that is the basis of case studies to be presented in this workshop. And finally, I am Khalid Pasha, and I head the Asia program for protected areas for IUCN Asia Regional Office here. So without further ado, I will just hand it over to Dr. Risa to take this workshop forward. And thank you so much, all of you, for joining this workshop.
Thank you, everybody. Sable, you could start the presentation. Share your screen. There we go. This workshop is part of a bigger project to develop best practices guidelines for climate change mitigation in protected areas. This project is going to focus particularly on this particular workshop on case studies from Asia, but the project is global in nature. The next slide. This is a 3-year project. We're about halfway through it. We started with a survey of the needs of protected areas managers, which we've completed. And the purpose of that was to give us a better idea of what kinds of information and how to present it that would be useful for protected areas managers and also for policymakers in the protected areas field. Then we were doing a draft report, a technical report, and that will be ready for peer review in early 2024. And if some of you are interested in being part of that peer review process, you can contact us. Our information will be, and then there'll be a companion report profiling successful case studies and lessons learned. We have a technical drafting team of 25 authors from around the world. We have a Protected Areas Managers Advisory Group, and we're hoping to do an interactive communication product that will make the information more accessible. The next slide, please. Next slide, please. Next. Yes, so so far we have 27 case studies from around the world. Oh, could somebody mute their, if you're not speaking, please mute your, yeah, thank you. In this map, this just gives you a rough idea of where these case studies are from. The blue triangles are ones that are not going to be talked about today, and the yellow triangles are the 4 that locate the 4 that we are going to be talking about today. So, and we are open to, of course, collecting more case studies. We have 27 at the moment. And at the end, if you have a case study of your own work that you'd like to be part of this profiling the case studies, please contact us and we'll tell you how to be involved in that. So this, then the next slide, please, Sable. This project is a sort of a companion project to another report on climate change adaptation. Whoever has their microphone, could they mute it, please? It's part of a bigger project, another project on climate change adaptation that was also done by the World Commission on Protected Areas in 2016. And this report really gives you a lot of information on ecosystem-based management and how to implement it in your protected area, and it's available on the IUCN website. Then I just want to give you a little bit of housekeeping. We'll hear from 4 speakers today. Each speaker will provide a 6-minute summary of their case study, highlighting climate change mitigation in protected areas in Asia. The presentations will be followed by a brief question and answer period prior to the next speaker. Following all of the presentations, we'll be opening the floor to a wider discussion. And you're welcome to use this time to ask additional questions or briefly tell us about a related project that you're involved in or raise issues that might have arisen from the presentations. We'll be closing the workshop with a brief synthesis and final remarks. The whole workshop will be approximately 1 hour and 40 minutes, but we really hope that if we go a little bit over, that you'll be able to stay with us. I ask you to please mute your microphone if you're not speaking. Somebody's microphone is open. Thanks. Thank you. Finally, the speakers are reminded, which you already have done, to try and keep to your time, and that Alex McDonald, who I'll introduce in a minute, will be putting up his electronic raised hand if you reach the 5-minute mark. So now I'm going to introduce Alex McDonald from Parks Canada. He's going to provide a brief summary of the results of 2 workshops that have been completed prior to this one. One for North America, Latin America, and Africa, and another on a different topic, which he'll talk about. Alex is an ecologist and works with Parks Canada, where he's the National Science Advisor and the manager of the agency's Climate Change Science and Advisory Team with the Office of the Chief Ecosystem Scientist. Alex's team provides climate change science, knowledge, and expertise to protected area managers to address current and emerging climate change issues in the establishment and management of the sites that Parks Canada administers. The team's projects include Parks Canada's groundbreaking Forest Carbon Atlas study, which we won't be talking about today, but you could learn about from the summary of previous workshops, and developing a database of climate impacts and adaptation options research to inform site-level management decisions. So Alex, over to you.
Great. Thank you so much, Risa. It's a pleasure to be here today and to have the opportunity to present a summary of the previous two workshops, which were co-hosted by Parks Canada and the World Commission on Protected Areas. The first workshop, which took place on May 23rd, featured several international case studies of projects implementing nature-based climate solutions in protected areas, in support of both the Best Practices Guidelines for Climate Mitigation in Protected and Conserved Areas, which Risa is preparing, and in support of the International Protected and Conserved Area Joint Statement on Climate Change and Biodiversity, which was signed by protected and conserved areas organizations around the world at the UNFCCC COP26 event. Next, please. So this first workshop included presentations by Parks Canada, the Congo Basin Conservation Society, and Environmental Conservation Society Kivu, the Europark Federation, Parks and Wildlife Finland, the Ontario Ministry of Natural Resources and Forestry, the 1.5 organization, the University of Maryland, and Ohio State University. You can see on this slide the presentation titles and each of the presenters from the respective organizations. This first workshop highlighted a broad range of projects, as you can see, from protected and conserved areas around the world that demonstrate their important role as nature-based solutions for climate change. The presenters also highlighted the role of process in improving ecosystem services for climate mitigation and adaptation in both new and existing protected areas. The role of technology to identify synergies between climate change action and biodiversity protection was also highlighted in several presentations, as well as the importance of innovation and using tools from outside of the protected areas world, which can enhance the resilience of protected areas to climate change. Next slide. The second workshop, which was held on June 6th, showcased projects that implement greenhouse gas emissions reductions related to operational activities in protected and conserved areas in support of the International Protected and Conserved Areas Joint Statement. Presentations included organizations such as One Planet Consulting, several presenters from Parks Canada, the South Downs National Park Authority in the United Kingdom, the Lake District National Park Authority, also in the United Kingdom, the U.S. National Park Service, and the Institute for Nature Conservation in Albania. And those presentations help to demonstrate and share knowledge on valuable tools, approaches, and lessons learned to address climate change mitigation objectives and commitments in the operation of protected and conserved areas. The second workshop also highlighted how protected and conserved areas managers are really demonstrating leadership and promoting the measurement, monitoring, and tracking of various targets to inform decision-making, to use evidence, provide evidence to inform decision-making, while also driving behavioral change and shaping hope and ambition for our shared responsibilities to address climate change and the biodiversity through protected and conserved areas. Next slide. The next two slides show the locations globally of the signatories to the joint statement, which is what you see here. And next slide. And the locations of presenters of WCPA, or World Commission on Protected Areas case studies during the first workshop. As you can see, we had quite a broad range of international representation. Next slide. And finally, if you'd like a copy of the joint statement, the link is here. And for summary reports from the previous workshops, please feel free to contact me. Next slide. And thank you. Before we go into the next presentations, we're requesting that workshop attendees, and this is a bit of housekeeping, we're requesting that attendees please write questions for the speakers in the chat throughout the workshop. To adhere to the time constraints of the workshop, we'll have a moderator read out the questions from the chat, rather than allowing each participant to verbally ask the questions. Thank you in advance for your thoughtful questions to all of the presenters. I'll now introduce our next speaker. Dr. Hong-Chul Park completed his PhD in forest ecology, climate change, carbon neutrality, and the REDD+ mechanism. He's currently working with IUCN's World Commission on Protected Areas and as a ranger and researcher with the Korea National Park Service, where he is working to monitor the effects of climate change on parks. Dr. Park's presentation is titled Introduction to Terrestrial Ecosystem Carbon Storage and Absorption Assessment Project in Korean National Parks. A quick reminder to Dr. Park to please prompt the slide change by saying next. Thank you.
Thank you, Alex. Hello, everyone, guys. My name is Hong-Chul Park from Korea National Park Service. Meet you. And it's an honor to present in such a meaningful today. So my topic is Introduction to Terrestrial Ecosystem, Carbon Storage and Absorption Assessment Project in the Korea National Park. Next slide. Recently, global climate change has become a shared concern of humanity, and carbon neutrality has emerged as a key strategy. So many countries have announced to achieve carbon neutrality by 2050. And Korea is also actively participating in this trend. Korea has declared to reduce greenhouse gases emission by 40% from the 2018 levels by 2030. And government policies are being implemented to achieve this goal in many parts. In particular, there is focus on utilizing ecosystem for greenhouse gases reduction. So we are conducting a monitoring project in National Park to assess greenhouse gases stored and observed by ecosystems. Based on this data, we aim to make the conservation strategies that are maximizing greenhouse gases storage and absorption capacity. Please, next. I'll continue to figure out the process of greenhouse gases storage and absorption in ecosystem. Trees absorb atmospheric carbon dioxide through photosynthesis of leaves. Carbon absorbed by plants is stored in the form of organic carbon in leaves, branches, stems, and roots. And leaves fall due to seasonal changes are decomposed by microbes. And carbon is stored in the soil as organic carbon. Accumulation of carbon over time in plants and soil, that is the carbon storage. On the other hand, there is carbon dioxide released back into the atmosphere through soil microbial respiration. So we are quantitatively assessing each of these aspects, absorption, storage, and emissions in ecosystem. Next slide. Yeah, our monitoring project began in 2021. We have established protocol for a scientific monitoring system. So starting this year, we are conducting a 3-year monitoring project of assessing that ecosystem carbon dioxide absorption in national park. Next slide. There are a total of 22 national parks in Korea. Our monitoring covers 22 all national parks, and you refer to figure for the specific location of each park. Next slide. In 2021, we completed the assessment of carbon storage all national park. A total of 347 million tons of carbon dioxide equivalent, 219 million tons stored in vegetation, and 128 billion tons stored in soil. This carbon storage per hectare is 1.8 times higher than the average carbon storage per hectare in Asian forests as reported by FAO. Next slide. So we conducted assessment for carbon storage and absorption and emissions for each carbon sink type. There are 7 types: deciduous forest, coniferous forest, mixed forest plantation, and subalpine coniferous forest, and wetland and meadow. So due to limitation in surveying the entire area, we established 222 sample plots in the field. Next slide. The assessment of vegetation carbon absorption by evaluating the increase in carbon storage for a year. Therefore, using the same method as used for carbon storage assessment in 2021. We are re-evaluating the carbon storage of vegetation this year. Essentially, in each sample plot, we survey the species and diameter and height of all trees. We use a biomass calculation formula developed according to a national standard. Each tree is labeled as shown in the figure, and survey result of trees are maintained in a historical record. Next slide. The assessment of soil carbon emission is conducted through direct measurement method in the field. First, measurement plots are established to remove roots in the soil. At these plots, we directly measure carbon dioxide emitted through soil microbial respiration. Since carbon dioxide emissions is correlated to soil temperature, so our measurements are taken seasonally to calculate annual carbon emissions. Next, please. So upon completion of this monitoring project, we will propose reflecting the carbon storage and absorption data as a national statistics. So we aim to make the public understand the carbon storage and absorption functions of protected area, and we expect to use for protected area policy supporting expansion and preservation of the project area. Thank you very much.
Thank you for the presentation, Dr. Park. We have a question here. Is there any advice that Korea National Park Service can provide to other jurisdictions on the challenges, including carbon stores in the management of protected areas? This question is provided in the chat as well. Thank you.
The most important management strategy we consider is to protect and conserve and management for trees within protected area to ensure they continue to alive. So that is basic of basic. This is both of fundamental factor and most important. So the forests and trees, when alive, will continue to grow and continue to store carbon more and more. So if trees die and soil becomes degraded, or the carbon stored in trees and soil will be released. So ecological destruction caused by events like wildfires and some various development projects and mass mortality event due to climate change. So we need a strategy for predicting and prevention before they happen. So the method of maximizing carbon storage and uptake in ecosystems maintain and conserve and protect forests in a healthy and complex state. So this involved preserving trees to prevent the loss of stored carbon and ensuring that trees can grow abundantly to enhance carbon uptake. So as forests become healthier, the diversity and quantity of microorganisms increase, potentially leading to higher emissions of carbon dioxide through soil microbial respiration. So this paradox presents a challenge that we will need to address moving forward. Balancing these opposing factors will require careful consideration for ongoing effect. Thank you.
Thank you, Dr. Park. I will send it to Alex to introduce our next speaker.
Great. Thank you, Maddie. Thank you, Dr. Park. The second presenter in today's workshop is Akash Lamba. Akash Lamba is a conservation scientist, climate change researcher, and engineer dedicated to making the world a better place through innovative and impactful research. Combining an MSc in conservation science from Imperial College London with a BSc in electrical engineering from Purdue University, he applies a multidisciplinary lens to craft nature-based climate solutions. Presently a PhD candidate at the NUS Center for Nature-Based Climate Solutions, Akash's research uncovers the climate change mitigation potential of biodiversity conservation in Asia. Today, Akash is presenting on the climate change co-benefits of tiger conservation in India. A quick reminder to Akash to please prompt slide changes with the word next. Thank you.
Thanks, Alex. Am I audible?
Yes, you are. Yes, you are, Akash.
Okay. Thanks. Hi, everyone. Thanks for being here today. So I'll be presenting some of the results from our research, which looks at essentially creating a biodiversity first approach to addressing climate change. Next slide, please. So biodiversity is increasingly being framed as a co-benefit of carbon sequestration projects, especially through REDD+. And in this case, biodiversity is more of a secondary benefit. Can you click on the next? Sorry, this has animations. Yeah, so forest carbon projects with biodiversity co-benefits do tend to perform significantly better in terms of a demand for them as well. But in this case, the issue is still that biodiversity often ends up being a second fiddle to a carbon-focused approach. But what we aim to do with our research is to create a biodiversity first approach where biodiversity conservation is a primary goal, and we try to quantify the ancillary benefits of these species-focused interventions. Can you click on the next slide, please? Yeah, so flipping this narrative around to make biodiversity the primary goal is a novel paradigm for aligning the resources that go towards conservation and climate change mitigation. Next slide, please. So to study this, we looked at tiger conservation in India as a study system. Can you just keep clicking through the slides, please? Yeah. Back. Yeah. So now tigers are some of the most well-protected species in India, and they've been protected since 1973. And to enhance the protection of tigers, in 2005, a National Tiger Conservation Authority was set up in India, which notified important reserves as specific tiger reserves in the Gazette of India. And this entails better management, better funding, and visibility for these reserves. Next slide. So the question really was that, does better tiger conservation lead to better forest preservation outcomes, and does that in turn lead to lower CO2 emissions from land use change? So that was the primary hypothesis with this piece of research. Next slide, please. So we looked at quantifying the avoided emissions from reduced deforestation from this better protection of tigers over the past 2 decades to see if better conservation did actually lead to this additional benefit of reduced emissions. Next slide. So to do so, we used an innovative statistical technique called synthetic controls. So the issue with doing studies in the real world is that the real world is not like an experiment. So we don't actually have perfect controls to compare something against, right? So to simulate a situation or an example of what would have happened in a tiger reserve had this intervention not taken place, we use this method called synthetic controls. Can you click through the next slide? Not the next slide, but the next animation. Yeah, so back, please, sorry. So essentially, since we don't actually have an example of what would have happened had the conservation intervention for tigers not taken place in a reserve, we need to simulate this model using a statistical technique called synthetic controls. So what that basically does is that the reserves in red in this map represent protected areas that did not undergo this additional species conservation, while the blue is a tiger reserve. So using this method, we can actually simulate what would have happened in this reserve had this intervention not taken place in terms of the projected deforestation. And the methods are quite involved, so I'm happy to answer any more questions about those in detail if you have any questions later. Next slide, please. So what this method essentially does is that it matches this model to what actually happened before the conservation intervention took place. And then this model is extrapolated into the future. So the dotted line represents what would have happened in terms of total forest loss had tigers not been protected in these regions. And then the gray line actually represents what happened in terms of real deforestation. And the distance between these curves essentially represents how effective a strategy has been in avoiding forest loss. Next slide, please. Yeah, next slide. So and then once we have this number of avoided forest loss per reserve, this can be converted into a biomass value in terms of what the avoided loss was in terms of tons of carbon dioxide equivalent. And then we can convert this also into a monetary value in terms of the avoided social cost of carbon, as well as potential revenues from the carbon market. Next slide, please. So I'll just run through the results really quickly. Can you click through all of these points just to have them all on the screen, since we only have about 40 seconds? Yeah, just no, the next slide, please. Just click through all of the points. Yeah. One more, I think there's one more point. Yeah, so essentially what we realized was that around 15 of these tiger reserves actually exhibited significant climate benefits, and over 5,800 hectares of forest loss were averted as a consequence of species protection alone. And this corresponds to about $93 million in ecosystem services from the avoided social cost of carbon, which is a huge benefit in a country like India. And this would actually represent a revenue of about $6 million in carbon offsets had these been integrated into carbon markets as well. Next slide, please. So finally, I just want to leave you with this thought that this can produce a novel paradigm for conservation where demonstrating the climate benefits of protecting charismatic species like tigers can actually generate money that can go back into conservation. So it creates this virtuous cycle of funding. So we see that about a quarter of tiger protection costs were actually paid back as avoided social costs of carbon. So it creates this model that we can work towards where the carbon benefits from species conservation do actually end up paying for a large percentage of themselves. Next slide, please. Next slide, please. Okay, so I think that's all that I have. If you have any questions, please do feel free to write to me. I know that's a lot of content to compress into 6 minutes, but I'm happy to answer any questions now. Thanks.
Thank you very much for that presentation, Akash. We do have a question from the chat that is asking, did you find correlation between the tiger conservation, deforestation, and climate change?
Thanks, Maddie. Yes, we did actually. So So reserves that did undergo this additional level of protection aimed at tigers did actually demonstrate a lower rate of deforestation compared to a hypothetical situation. So we had to create this counterfactual. So in a simulation where these reserves would not have undergone this additional protection, they would have actually lost additional forests, and the number is about 5,800 hectares. And any avoided deforestation actually represents climate change mitigation, right? Because we're essentially keeping more carbon in the ground. Whereas if a forest is cleared out, that forest carbon sort of that is locked in within these forests is lost into the atmosphere. So yes, there was a positive correlation between tiger conservation and avoided deforestation, which consequently led to avoided emissions as well. So it sort of creates that entire value chain of better species conservation outcomes leading to avoided deforestation.
Thank you very much, Akash.
Thank
I
you.
will hand it over to Alex for the next presenter.
Great, thanks so much, Maddie, and thank you, Akash. The next presenter is Brigitte Gunawan, who is a National Geographic Young Explorer, winner of the Ocean Awards Young Initiative by Blue Marine Foundation in partnership with Boat International, and an EE30 Under 30 by the NAAEE. She is part of the Asian Youth Network for Protected Areas established during the Second Asia Parks Congress in Sabah, Malaysia. In 2021, she launched 30 by 30 Indonesia, a movement igniting community engagement to advance marine protected areas in her country and support the global goal of protecting 30% of the ocean by 2030. In other words, 30 by 30. Today, Brigitte will be presenting Climate Change Mitigation, Community Efforts for Coral Reef Restoration in Tulamban, Bali. My apologies for any mispronunciation. A quick reminder to Brigitte, again, to please say next when the slides should advance. Thank you.
Thanks, Alex, for the lovely introduction. Hi all, my name is Brigitte, and I'll be sharing about my experiences in spearheading climate mitigation efforts, basically through community involvement, and to use that as a driveway to get to coral restoration in Bali, Indonesia. And given the community driven aspect of this effort, it is quite unique in the way that we have approached things. Next slide. So the efforts I will be mentioning here is located in the Tulamban village, specifically in the Karangasem Marine Protected Area, which is pointed by the arrow on the top right corner of the screen, and it is in the northeast coast of Bali. Next slide. So the approach here is to take on active reef restoration, and it is essentially a way, it's a nature-based solutions to restore local reefs and also increase public awareness through the on-the-ground community engagement aspect, especially because the restoration site is located in a popular diving marine tourism site, specifically located next to the Liberty shipwreck, which is located pointed out by the yellow rectangle on the center of the screen. That's where the reef restoration is being held. And we know that coral reefs are very important and are an effective method to mitigating climate change. It is also being heavily impacted by climate change. So the method of actively restoring these reefs is also very important to help recover these ecosystems. Next slide. So the restoration side we are looking at, I'll be referring to as the 30 by 30 Coral Garden. It is called the 30 by 30 Coral Garden because it's focused on an underwater message. Essentially, it takes form of the number 30 by 30 on the ocean floor, and it was launched in Earth Day 2022. It's pretty recent, and our approach was taking on the coral gardening method, which involves two phases, the first one being nursery and the second one transplantation. And it is considered one of the most effective restoration approaches. To sum it up, it is an artificial reef, and our purpose and our approach is to involve the community through like local diving coalitions, the local youth, in spreading that public awareness about how important marine protected areas are and how coral reefs are very important to mitigating climate change, while especially because they are a community very driven by the ocean's impacts and also the climate change that is affecting these reefs. Next slide. So just to briefly sum up the implementation process, there are three main stages that we approached it with: before, during, and after the dive. So the first and most important thing is the site determination, and we specifically chose this site, which was a shore dive. It was not an open water dive, so this means that we can go in the water right away directly from the shore. We didn't need any boats to get to the site, and we sourced the baby coral fragments from an organization in Bali. And we also collaborated with local diving coalitions and volunteer divers who are very keen to contribute their efforts to both deploying the substrates, transplanting these corals, and also maintaining and monitoring them in the months to come. And during the implementation, it was divided into 1 to 2 day events. So the first dive would include deploying the substrates. This includes reef frames and also concrete structures. And during the surface interval, we would have a public awareness initiative. This would take the form of engagements and discussions and presentations by the experts with the local members of the community. This includes young children and junior school, high school, other youth members, and also local collaborators. And we also try to maintain the corals to have minimal stress by having quick and careful handling. Before going into the second dive of the day, usually we would have a coral transplantation on the same day or the next day after that, which is considered the second phase, the gardening phase, within the reef restoration. And after the actual installation of that garden, we would have weekly monitoring in the first 3 months, and then post that, we would have once every month. And again, this is still ongoing, so this is just sort of the first stage of the coral garden that we're planning to develop, and we are experimenting with different methods. Next slide. So some of the measures of success, this is a brief summary, but this is based on field data from 2022. We looked at fish diversity and coral survival rate, which was pretty good, considered categorized as pretty good because it's over 70%. And we involved at least 80 locals who were part of the public awareness initiative. Next slide. So to sum up the challenges that we have faced, one of the most challenging aspects is the fact that the site is located about 3 to 4 hour drive from the main city where most of the volunteer divers are. And it is also quite difficult to source these substrates and transport them. And we also require the active monitoring of the human intervention to manage the blooming algae, which is also another challenge that we have seen. There is an excess growth of algae, which needs to be brushed off manually by the divers. And next slide. I guess that's all from me today. Thank you.
Thank you very much, Brigitte, for your presentation and for your impressive youth work on climate action. I will ask a question from the chat. I know we've had a couple from the chat, so if you've asked the second question, that will come up during the discussion period of this workshop. The first one was the 30 by 30 shape. Does the design have a particular effect on the effectivity of coral reef rehabilitation?
That's a great question. So this design itself does not, at the moment, we do not correlate it with the effectivity of the coral reef rehabilitation. It's more towards, catered towards informing the divers, because it's located next to a diving site, a popular diving site. It's more about the divers that pass by or the local dive guides who lead these dive tours to talk about the the protected areas, to talk about the goal and be more aware of the 30 by 30 goal while people are like going snorkeling or diving around that side. So it's more catered towards the education and public awareness side.
Thank you very much for that, Brigitte. I will hand it over to Alex for the introduction of the next presentation.
Great, thanks again, Maddie, and thank you again, Brigitte. Today's fourth presenter is Yusmiana Rahayu. Yusmiana is a PhD research student at the University of Western Australia at the School of Biological Sciences. She is also a researcher from the National Research and Innovation Agency, BRIN, in her native country of Indonesia. Her research interest is in blue carbon ecosystems, and today she will be presenting Blue Carbon Study, a Nusa Penida Marine Protected Area, Indonesia. A quick reminder again to Yusmiana to please prompt for the next slide by saying next. Thank you.
Well, thank you, Alex, for the introduction. Hello, everyone. I'm Yusmiana, and I'm so happy to be here. Thank you, Risa and Maddie, for inviting me into this workshop. I'm going to share my experience on the study in blue carbon in Indonesia, and one of the location of the project is in marine protected area in Nusa Penida. Next, please. So just a little bit of introduction for some of you that might not be familiar with the term. Blue carbon is organic carbon that is stored or sequestered in vegetated coastal ecosystems such as seagrasses, mangroves, or tidal marshes. So this term is firstly coined in 2009 with the publication from Nelleman 2009, as you can see in the slides. And currently, some of the countries are working towards incorporating marine sector into their climate change mitigation strategies, as some studies prove that this blue carbon ecosystem can store a huge amount of carbon in their biomass and also sediments. And in reverse, if these ecosystems are degraded, they can release huge amount of carbon dioxide into the atmosphere, so making them creating more emissions. Therefore, protection and conservation, also restoration of this blue carbon ecosystem is very important. Next, please. Yeah, I'm joining in the carbon research group in Indonesia in the National Research and Innovation Agency, and one of our study sites is in Nusa Penida, and we did this long time back in 2014. And to show you the location, this is Nusa Penida Marine Protected Area. It's close to Bali. I think most of the people knows Bali, and Nusa Penida is the islands next to Bali, and it consists of three islands actually: Nusa Penida, Nusa Lembongan, and also Nusa Ceningan. As you can see in the map there, the mangroves and seagrass are mostly located in the dark green area. So the Marine Protected Area of Nusa Penida established in 2010, supported by the central government, Ministry of Marine Affairs and Fisheries. And the management in the area is shared management between national government, state and NGO, and also communities. Next, please. So these are the results of the studies. We studied mangrove health index in Nusa Penida Marine protected areas. So it's already published in 2018. This study, if you are interested in this study, you can just search the title and you can find the paper. So basically, we use remote sensing technology to monitor the spatial and temporal changes in mangrove coverage and density from 2003 to 2017. So 2003 we start because the tourism started to grow in Nusa Penida, which is increasing economic activities in the area. And 2010 was the establishment of MPA. And then if you can see the result here in the slides in 2017, this is the mangrove coverage, so it's look more green, dark green. So the establishment of MPA give positive impact on mangrove health index in the area. Because if you can see here in 2003, 2010, the yellow color, bright yellow, means non-vegetation cover, while in 2017, it's more of dark green color, so more mangroves are found in 2017. Next, please. We also did also measured carbon stock in biomass mangrove. This study is published in conference proceeding in 2014 with the title "Blue Carbon Stock of Mangrove Ecosystem in Nusa Penida." We did field work in 2014. We took samples from 5 stations, as you can see in the table there, and we found 5 species of mangroves. And we also took samples of stem, leaves, flower, fruit from each species to analyze carbon and nitrogen concentration in the laboratory. So the result from the study, you can see in the table there, we measure total above ground carbon and also total below ground carbon, and we convert them into megagram carbon per hectare. And the above ground carbon was about 26.9 up to 140 megagram carbon per hectare, and below ground carbon is about 13 up to 47 megagram carbon per hectares. And the total carbon average is about 90.72 megagram carbon per hectare. Next, please. And this was the recent publication from the study in Nusa Penida. We compare the sedimentary seagrass carbon stock between 3 different areas, which one is MPA, and disturbed area and also undisturbed area in different islands in Indonesia. So we took samples from seagrass in Nusa Lembongan. We found 8 species of seagrass in Nusa Lembongan, and we got 5 sediment cores from the location. And we had a great opportunity to analyze the samples in Germany at the time under the collaboration project. Because one of the challenge of blue carbon studies in Indonesia is the facilities of laboratory. We have very limited number of lab that have the ability to measure carbon in the sediment and biomass. So as you can see, the result here in the graph, the carbon stock in marine protected area is the highest, which is about 77.15 megagram carbon per hectare. It's the highest compared to disturbed location and also undisturbed location. And we also got the stable isotope data from the elemental analyzer. It's the method that we use. So we can measure the sources of carbon stock using stable isotope mixing models. And from MPA, we found that the primary sources of carbon come from seagrasses, which is about 36.4%, while in undisturbed areas, it's mainly from seagrass, and in disturbed areas, mainly from coastal particulate organic matter. So it's already published, the paper. If you are interested, you can just find the publication. Next, please. This is just a general method that we use for blue carbon studies in Indonesia. We follow the, can you please click one more? We use the Coastal Blue Carbon Guideline from the Blue Carbon Initiative. It's Howard et al. 2014. It should be there in the slides if you click next. And yeah, the photo there, we took samples from using PVC pipes, and then this is when we do laboratory measurement in Germany using the elemental analyzer. Next, please. I think, yeah, that's all we can share from our experience in Nusa Penida. It was a great study there. And if you want to know more about it, you can just contact me through email, or you can also visit our social media, Blue Carbon Indonesia, to know more about our activities. Thank you very much.
Thank you, Yusmiana. I will now ask the first question from the chat. If your question is not asked right now, we will in the discussion period, and then there will be time for us to allow for the presenters to respond after this workshop if your question's not gotten to in this workshop. The first question was, what are the major impacts of climate change in mangrove and seagrasses in the ecosystem?
So if I understand correctly, what is the impact of protection?
The question is, what is the major impact of climate change on mangroves in the ecosystem?
Okay. All right, thank you for the question. Yes, the impact of climate change on mangrove and seagrass. We all probably heard that there are some disaster happening more and more, like for example, marine heat wave, where the temperature in the ocean are increasing, and it's not only affecting coral reefs that we heard previously in the previous presenter. It's also affecting seagrasses, where when the temperature is very high, then it's hard for the seagrass to continue living. So many of them will die, and then they will also releasing carbon dioxide into the atmosphere. And it's same like for mangroves. Mainly the problem is about the sea level rise, and also the ocean acidification, and also the raising of temperature. Yeah, we can find some of the case that climate change affecting mangrove and seagrasses.
Thank you very much, Yusmiana. We will now begin the discussion period of this workshop. If you have any initial questions for all of the speakers that you have not added yet into the chat, please do so now, and we will try to address all of them. Once we have asked one question to each speaker, we will also open the floor to a general discussion. We might ask several questions to each speaker depending on how many have come into the chat. If you would like to add to this discussion after all of the questions have been asked and there are time, just feel free to raise your virtual hand and we will call upon you for your comment or question. This discussion period will be concluded by a Mentimeter. Folks can use this to ask any additional questions they may have for speakers following this workshop, and we will get back to you, all of the registrants and participants of this workshop, via email with all of the replies from our speakers. We do have limited time, so we may not get to everyone's questions today. We will get to as many as we can. I will begin this discussion period with a question for our initial speaker, who is Dr. Park. This question is from Nafel, and he is asking, what are the overall results of your study? So Dr. Park, we will get you to answer this question. I will type this question in the chat as well, so you have a visual of this question.
My presentation is more about monitoring project than research.
Sorry, Dr. Park, you might just have to speak a little bit louder. I don't think we can hear you quite yet. And if everyone else could just turn off their microphone for while Dr. Park speaks, that would be great.
Okay, my presentation is more about monitoring projects than academic research. So through this project, we learn how much carbon storage in national park is, and we were able to inform the public of these results. So, and it is important that the carbon storage in national parks is higher than that over ordinary forests. Indeed, a high carbon storage indicates that the trees in that area have observed and stored a significant amount of carbon dioxide from the atmosphere over an extended period. So it underscores the importance of conserving and managing these trees to ensure their continued well-being. So such actions contribute directly to climate change mitigation efforts. Thank you.
Thank you very much, Dr. Park. I will follow this question by a question for our next speaker, who is Akash Lamba. We have a few questions from the chat for Akash. I will begin by the first question and we'll follow to the next speaker and then return to you if we have time. Otherwise, again, we will respond to these questions via email after this workshop. The first question for you is, does the protection of tigers have anything to do with climate change mitigation, or is it just the creation of the protected area? Protected areas in India may give the same benefit.
Thanks for that question. So actually, what we did was we compared pre-existing protected areas to protected areas that had that additional level of protection to make sure that it wasn't just so this result wasn't just an artifact of a piece of forest being protected, but rather it was an already protected area that received additional protection through the introduction of better funding mechanisms, the usage of technology. So, for example, the software M-Stripes, which is something that rangers in India use for tiger protection, that's been hugely successful as well. And then finally, there's also an emphasis on benefit sharing from ecotourism as well for the community. So it's all of these additional steps which are enacted within already established protected areas, which lead to this additional level of the avoidance of forest loss and degradation.
Thank you, Akash. And again, we will get to the further questions if there are time at the end.
Thanks.
The next question is for Brigitte. Sorry, just one moment. Brigitte, did you, during your study, face any transboundary issues since your study is using coral?
Yeah, if I understood it correctly, short answer, yes. We did face transboundary issues. Just because we know that corals are very sensitive to climate change, and these are often driven by global stressors, like a very slight change in temperature and pH can always make a huge difference to these coral reefs. And we have seen that in the excess bloom of algae and whatnot. But although we know that these are global stressors, and that we know that it's located in a marine protected area, marine protected areas cannot fully guarantee, safeguarding the global stressors, but it's more directed towards local, combating local threats. So, yeah, there has been some issues there.
Thank you very much, Brigitte. The next question is for Oceania. I'm sorry. Oceania, were the carbon stock in sediments measured, and if they were, up to what depth were they measured?
Yeah, thank you for the question. Yes, we did measure the carbon stock in the seagrass sediment, and we use stainless steel core at the time, and the depth was varied about 30 to 70 centimeters. And then for the calculation of carbon stock, we standardized them into 1 meter to be able to compare with other studies.
Awesome. Thank you very much. I will return to Akash, who has the next question. The question is, what are some measures taken to mitigate human and wildlife conflict in India?
Great. So thanks. That's a great question actually, because as tiger numbers do increase, conflict does seem to be on the rise. And there are a number of measures that are being taken place that are being implemented, such as livestock insurance, because some of the biggest financial losses from the human-wildlife conflict in India is through the depredation of livestock, because a lot of communities are highly reliant on livestock in these areas. So the introduction of this livestock insurance has helped, but again, I think there is a drive towards more benefit sharing through ecotourism. So ecotourism sort of creates this alternate livelihood, and it does bring in a fair amount of income to communities that do share space with these big cats. And I think it is a work in progress, and I do think that there does need to be an emphasis on making sure that the communities in this region do benefit from conservation, because at the end of the day, they're sort of the primary custodians and the stakeholders of these areas. So those are just some of the few measures that I've sort of been acquainted with. But again, there is a need to introduce more technology as well. So these are things like deterrent systems for avoiding adverse outcomes like livestock depredation and human loss of life as well in certain cases. So yeah, those are some of the measures that have been taking place.
Thank you, Akash. There are a couple more for you, and we do have some time, so I'll just jump into the next question right for you. Someone is saying, I'm interested to conserve tiger conserved protected areas. Was there any human and tiger conflicts? Was there any village settlements around the protected areas? He caught at some points you studied about reducing the deforestation rate related to carbon emissions. Have you noticed an impact, a social impact by tiger conservation?
Okay, thanks. There's a few questions in there. Starting with the first question, right? Yes, there has been a human-wildlife conflict, especially in reserves in northeastern India. I mean, some reserves, like I don't know if the audience is acquainted with the geography of India, but some reserves like Pilibhit do have a fair amount of human wildlife conflict that does take place. So yes, there has been conflict, and that is something that needs to be addressed. And that adds to the social cost of conservation as well. And that is something that we hope to explore through subsequent studies. So currently our study only looks at climate change impacts, but adding a more holistic view to look at the social costs from things like conflict, that is something that we are hoping to look at as well. Yes, there are human settlements around in and around protected areas. So India is quite unique in terms of the fact that a large number of people do actually share space with some fairly charismatic and large carnivores like tigers, leopards, lions in Western India. So yes, it is sort of a complex matrix of humans and wildlife sharing space, which makes the need for more proactive conflict mitigation strategies more urgent. So the next question is about, I'm not sure I understand this question, but yes, there is a positive benefit to climate change impacts in terms of the avoided deforestation that takes place in tiger reserves. So the social impact, right? So there are two ways to look at this. There's obviously the cost to communities. There are a number of ecosystem services as well that lead to economic benefits as well. So the primary way that we used to we used to quantify this carbon benefit in terms of a financial gain was using this idea of the social cost of carbon, which essentially characterizes the financial damages to an economy from every additional ton of CO2 that is emitted into the atmosphere. And this is based on a study from Nature in 2018, which actually found that India is one of the most vulnerable countries in terms of the impacts of climate change. And this is through a number of estimates from things like failing agriculture, the effect of adverse weather events, and all of this is sort of estimated, and it comes to an amount of about $86 per ton of extra CO2 that's emitted into the atmosphere. So what we realized was about 1.08 megatons of CO2 were averted, which directly translates to a social cost of about $93 million, sorry, of avoided cost to the Indian economy. So that's the primary method that we used to quantify this this financial benefit. But again, we do look to sort of refine this further in the future with additional ecosystem services as well as social disservices from conflict. I hope that answers that question.
Thank you very much, Akash. If whoever asked that question in the chat, there will be time after we've asked all of the questions for you to raise your hand and directly ask Akash any follow-up questions. I will follow this by asking a question for Yuzmiana. The question from the chat said, nice PowerPoint and insights. Could you deep dive into the mangrove indexing system? Did you take into account any of the plankton or other biotic parameters while measuring the blue carbon stock?
Yeah, thank you for the question. For this project in Nusa Penida, we didn't go into details into mangrove indexing system, but in other projects, we also still doing more research on mangrove because many interests are put into that section now. And for planktons and other biotic parameters, in some location, we also took some water samples to measure planktons and also nutrients in the water, and to see the water quality and also to see the impact of water quality into the ecosystem, the blue carbon ecosystem, such as mangrove or seagrasses. But for this project in Nusa Penida, because it was like in 2014, we are focusing more onto the carbon stock and carbon stock in mangrove and seagrass. Thank you.
Thank you very much. There are two follow-up questions here. What method was used in the laboratory organic matter content / carbon content? And the other one was, did the distance of the site collection and laboratory distance affect the samples?
Yeah, for the first question, the method that we use to measure carbon content, as I put in the slides, we measure carbon using elemental analyzer, which is, if you see in the guideline, it's the most precise way of getting organic carbon data in blue carbon studies. So for the next questions, yes, the distance of the site collection and laboratory, yes, it is. It will affect the samples because we are dealing with biological samples. If we do the biomass, and also in the sediments, there are microbial stuffs in there. So we really need to be careful on doing sample preservation. Usually what we do, we use the cooler box if it's just short distance between the site and the site laboratory that we set up in the location, in the project location. So we just use the cool box and then put them in and then transfer the samples into the freezer. So they need to be kept frozen before the laboratory analysis to prevent the microbial growing in the samples. So that's what we did so far. I hope that's answered the questions.
Thank you very much for that response, Yuzmiana. We do have a question to all presenters. So maybe if somebody has a specific answer they would like to give first, feel free to jump in. The question is, may they get your opinion about range shifts? Will the range of ecoregions changing with the changing climate? How do we ensure important ecosystems and species are conserved through time?
I can take this one. So yeah, I think the answer is yes, there will be range shifts, and I think one of the most exciting. It's an interesting development. I think it came out in Mongabay today that the spatial overlap between leopards, snow leopards, and tigers is likely to increase as there are range shifts elevationally, right? And this is a concern, and I think there will have to be more of a proactive engagement from scientists, and there has to be a high degree of coordination between policymakers, scientists, and conservation practitioners. So all of this needs to be grounded in solid science, like creating habitat suitability models under changing climate scenarios, and proactively adjusting our conservation strategies, both spatially as well as what needs to be done at that time. So a good example of this is there has been research into dynamic protected areas. So having the actual boundary of protected areas shift, and that's something that will have to be looked at in the future. So yeah, I think it has to start with sound science, which models the potential habitat changes within different species, and then that has to translate into scientists working with policymakers and practitioners to create this sort of adaptive management strategy for specific species. I guess, I mean, that's what I think it needs to be done in a nutshell. But of course, it will vary by species. It will vary by the habitats that we're looking at, and geography as well, because socioeconomic constraints are key to look at as well.
Well, just to add more on what Akash just mentioned, I think the awareness of the people should be increased in terms of the importance of the ecosystems. For example, I'm just taking seagrass as an example. Like in Indonesia, most of the people are not really understand the importance of seagrass ecosystem. They just see it as a grass that is growing in the coastal, and it sometimes doesn't look really good. It sometimes looks like a, when it's detached from the roots, it looks like a rubbish, and they tend to remove them, and they don't really understand what are these where these ecosystems for. So I think for us as a scientist, and I think from IUCN, it's very important to increase the, to increase the awareness of communities through like campaign. It's more like a grassroots activities so that they will understand, oh, okay, so this could be used as a climate change mitigation strategy. So they really need to understand that that importance, I think.
Thank you very much, Akash and Yuzmiana. Does any other presenter have anything else to add? Otherwise, I will move on to the next question. Awesome. Okay, so the last question here is, says myself, Parvez is from EMPRI India. They're working on fireflies in Western Ghat, India, as fireflies are drastically declining throughout the world, but we still have pockets where they can be found. Their question is how we can protect them in their natural habitats, or how we can establish a protected areas for them, such as firefly sanctuaries. Though the species is not under protection law and the IUCN Red List, how can WCPA help in declaring and protecting those areas? Perhaps more directed at someone from WCPA or the presenters.
Hi, Maddie, I can take that. Hi, everyone. Yeah, so regarding the fireflies question, I believe the person has written to us and I have directed them to the regional vice chair and other folks in India. So that's where we have to start. I think there is an email in that person's inbox which connects him or her to the right people in India. But the Commission can support by providing technical advice. But the creation of the area itself is really entirely up to the national system. Thanks.
Thank you very much, Madhu. If you could go to the next slide, please, Sabiel. Okay, thank you very much for all the presenters and to the audience for your thoughtful questions. If you have any additional questions that did not get answered today, please use this Mentimeter to ask them. You can use this Mentimeter you can access the Mentimeter by using the instructions on the screen. We will also provide a link in the chat, which I will do so now. Once you click onto that, there will be instructions as to how to ask the questions. So if everyone could just click into that, and I will provide further instructions as to how to ask the questions on that platform. And then following this webinar, we will have the presenters reply and we'll send out an email summary to everyone, all of the registrants. I'm just going to wait a couple moments while people join on the Mentimeter. If you have hit a thumbs up, that's a good sign, and we will switch to the next screen following your thumbs up. Awesome, I see many people are doing so. Thank you very much. If you're having troubles with this platform, feel free to write in the chat and we'll help you out. Looks like most people are able to join. Awesome. I will switch to the instruction slide here. So you can use this platform to ask questions to the presenters. Just a reminder of all of our presenters' names. We have Akash Lamba, Hongchul Park, Yusmianya Rahayu, and Brigida Maria. And using this platform, you should be able to write your questions. I will pass it back over to Dr. Risa Smith for a summary of the workshop today. If you could switch the slide, perfect. Thank you.
Thanks everybody for an amazingly rich discussion and particularly the questions and the great presentations. I'm going to try and do a very quick summary of some of the high-level messages from everybody's presentation and the discussions. Of course, I won't be able to reach all the detailed points. The first thing I got out of this was that many countries are investigating the use of carbon sequestration and storage abilities of their natural ecosystems as a component of obtaining targets to reduce greenhouse gas emissions. We had two examples of this, one on forested ecosystems in Korea national parks, presented to us by Dr. Park, and the other was in a blue carbon system in a marine protected area in Bali, presented to us by Yasmiana Rahaya. In both cases, detailed measurements at the local level were taken, which provided credible measurements of the carbon in these ecosystems. In the case of Korean forest ecosystems, the detailed work showed, among many other things, that there's more carbon sequestered and stored in Korean national parks forests than estimated by more global studies, such as those done by FAO. So if the country really does want to use their park system as a credible means of reducing greenhouse gas emissions, it's really important to do the more local measurements. We also learned in the case of the blue carbon that there's a lot of variability in global estimates of carbon in mangroves and seagrasses. And taking this detailed local measurement approach demonstrated the carbon sequestration and storage in these particular ecosystems, blue carbon ecosystems in Bali, which would be very beneficial for Indonesia to argue that their measurements are credible. It's a lot of work to create these kinds of detailed measurements at the national level or in a particular protected area, be it marine or terrestrial, but it is worth it and important if you want to have credible measurements of the relationship between carbon and natural ecosystems. The second thing I learned was something quite different. Most people, when they're looking at the biodiversity climate change nexus, look at biodiversity conservation as a co-benefit of climate change, sort of like a second cousin. But Akash Lamba turned this whole question around. He turned the paradigm around and looked at conservation as the main objective and showed that there are co-benefits for climate change from taking a conservation first approach. And I think this would be very important when we're looking at implementing the two conventions, the Convention on Biological Diversity and the new Kunming Montreal Global Biodiversity Framework, as well as the Paris Agreement from the UNFCCC. So here he showed that we could take a conservation approach, invest in conservation, and you will get climate change benefits. And although his study showed that directly, and it's very handy because he has 19 years of data on tiger conservation, there's other studies around the world that show the same thing, the benefits of both MPAs and terrestrial protected areas that are created specifically for conservation, but have co-benefits for climate change. So climate change is maybe the second cousin in that aspect, but it really argues for more investment in conservation first. And then the third lesson related to process. I think Brigitte Gunawan has showed us quite clearly that the process you use and the engagement of the public and the local communities can have a really big impact on results. So in her case, she used the local community and volunteers to do restoration. They do a lot of follow-up in terms of measurement and particularly communicating the results. And that ends up getting you buy-in to a protected area, in this case, a marine protected area, from people who are trying to make a living and might not otherwise be as interested in protection, except when they see the benefits and they are actually participating in those benefits. So, and there are many other lessons, and especially from the very rich discussion that we had. I want to thank everybody for their participation. This was a great workshop, especially the speakers, but also all the participants for your questions, and the organizers, especially Sable and Maddie, for their organization. And I hope that we can have follow-ups. We're very interested in your case studies. We have already 27 case studies from our project on climate change mitigation in protected areas. And you can reach us. I think maybe Sable, you can put on the last slide. Next slide. Here's all our, back. This is our contact information. And if you do have a case study that you want to contribute, send us an email. And Maddie and I have the same email, and we'll respond, send you the template, and work out how you can be part of this, this project. So thank you again, everybody, and thank you to our sponsors, particularly Korean National Park Service, Asia Protected Areas Partnership, the World Commission on Protected Areas, and for this particular workshop, Parks Canada and the Ministry of Environment from the Government of Japan. So thanks, everybody, and hope we'll meet again and that you'll be in touch with us again. We'll distribute the summary and all the presentations and the Mentimeter questions and responses within probably a week, within a week. Thanks. Bye, everybody. And we, I guess,